Hi everybody, it's Al, and I thought I'd do a follow-on video for solar panels and solar energy and wind energy. And we're going to look at it from the practical side, right? What is practical for the average consumer or homeowner? I do have an elaborate setup in here, but not everybody needs, this much power and all this stuff. We just decided that, in a case of something happening, and the grid going down, that we would have enough power to supply the entire house. And we're going to talk about what is practical and what isn't. So we have almost 5 kilowatts per hour production in solar panels, but we don't use all of it, but it's there if we need it. And we have 2 charge controllers, one here and one here, that get that power and feed it to the 2 banks of batteries, which supply power to the pure sine wave inverter, which is 4 kilowatts, and that feeds the house. Now, the way that I do this, and I've had some questions about this in the past, I have a little breaker panel here, and those are small 20 amp breakers for the most part. And what I do is, that is actually the sensing circuit that tells this guy whether we lost commercial power or not. It also feeds the battery charger that's built into this unit, into this pure sine wave inverter. It has a 55 amp battery charger, which, if I need to, can go ahead and charge the batteries, and it's very good in how it works, and you can set it up in different ways. But if I ever want to or need to do an equalized charge on my batteries, that is what I do to get my batteries up to range. So that is what we use all the time in production. Then I have a standby 3600 watt inverter that is not pure sine wave. That's a modified sine wave, and this is from Tripp-Lite, and it's extremely robust. That thing weighs about 55 pounds, and this is going to go into an EMP proof container. I've had it set up in here for testing purposes, and everything runs the whole house just fine. And then there's a transformer above that to make that power into 240 volts 2-phase. So that is my setup. But let's talk about what is possible with power and how do we use it in practicality. So let's take a look in here, and let me set up my camera here so you can kind of see what we're talking about here. Let's see. So as you can see, we have produced about 11.7 kilowatts today, and have used that much in power from the solar panels. So right now, my solar panels are producing about 61 volts at 7 amps, and it's coming out at 26 volts and 15 amps. And that is what we've been using for the day, and we've used almost 12 kilowatts today. And then I have this other charge controller that comes from my Harbor Freight panels, which has produced 2 kilowatts today, and right now it's putting 2.2 amps from an input of 58 volts that gets converted down to the 26 volts that goes to the batteries. So these are my 2 main power sources that come from solar. Now, this guy here goes and feeds my house. So right now, as you could tell from here, the breaker is turned off. And what that does, it tells my MagnaSine inverter that there is no power from the street, and it forces us into inverting the load. And right now you can see it's inverting 16 amps at 26 volts. So not a whole lot of consumption in the house right now. So I have a capacity to produce a lot more power than I in reality use, and I'll show you, how we actually use that. So every circuit in my home is fed by my power from the batteries by the inverters on two separate circuits, or sub panels I should say. The first one is out here, and the main breaker box coming to the house is that one. It also has the breakers for our shed, the water well, the water transfer pump that you saw inside, as well as all the lights and all my tools. And it also supplies power to that that side of the house, which is really a guest living quarters. It's a little guest house that is part of our home. And so we have all the circuits that we need to in the sub panel that drive the power for the guest house, as well as the shed, the power to the other metal buildings that I have, the other sheds and all my tools. It also powers the well. And so all I have to do is flip the switches here to put it online or put it on generator, and as soon as I do that, it automatically transfers over there. So because I have my pure sine wave inverter set up in such a way that as soon as I turn off that breaker that I showed you, it senses that it lost street power, it automatically begins feeding power here. So right now, all of this is being fed from my solar panels. So if we go to the other sub panel, I will show you how that is actually feeding the house, and I'll show you hopefully how much power is getting drawn through that. So here we are in the little guest house, and I'm still finishing this. Still got to hide all those panels, but that's part of our food storage there. And then, you know, we have a flat panel screen TV here, a nice closet with more storage inside for food storage, as you can see. It's kind of hard to see right now, but it is that food storage. And we have a bedroom here, and you know, has a TV, a dresser. There's a full bathroom in here with a shower, as you can see, and the place is well air conditioned. And how I did this room is because it's separate from the house. There's an actual water heater in here also, which is what feeds this entire location here. I just turned the light on. So that air conditioner is good enough to cool this entire place down beautifully. And I have this little fan this through the wall fan that actually pushes the air conditioning temperature from this room here into this big living area here. And then over here, it's going to be a kitchen. I still got to put the counters and the refrigerator and all that. But that's the idea here. Right now, it is my exercise room. The point is this. Here's the other sub panel that feeds my main breaker panel. And if we go take a quick look at it, here are the circuits that are being fed into the house. So right now, I'm drawing about 400 watts of one circuit and about 250 watts of the other one. And as you can see, all the circuits are set to generator with the exception of this guy here, and this guy here is my water heater, my home water heater. But my home water heater is not on solar because I have a solar water heater. And I think if you look through my videos, you will find that on the temperature it's quite hot. And then I have a solar disconnect here because I do have some grid tie equipment. I have 1.6 kilowatts of solar power that's grid tie, and that guy feeds in through here. So if I have an outage and my pure sine wave inverter kicks in, it actually tricks my grid tie inverters into also thinking there is power from the street, and it comes to work, and it begins feeding power to to my home. So what do we run with this? Well, we run everything in the house, absolutely everything, with the exception of the main AC, because the main AC would drain my batteries if I were to use it at night. During the day, it's okay. So in an emergency, I guess I could use it. However, that's not my plan. My plan is, if we ever had an emergency like that, we can A, relocate to this room where we have the emergency supplies. We have plenty of room in here for the three of us, our boy and my wife and I, and run so little power in here that we could run this fully air conditioned, have our kitchen and all the appliances, and be able to live a normal life in a smaller space, because I don't need to cool a whole house down. But if I wanted to cool a whole house down, let me show you what my plan B is. So I kind of profile how much energy it would take to cool my home. And this air conditioner here actually has a heat pump in it, so it is also a heater in the winter time. So if we look at how much power this guy is using, let's run it here. It runs 817 watts continuously, so that's a kilowatt an hour. So when it is on, and it's not on all the time, it turns off when it reaches the right temperature. But let's say that it runs half the time, so that's 12 hours at 800 watts. You can kind of do the math as 20% less than a full kilowatt at 12 hours. You're looking at maybe 8 kilowatts to 9 kilowatts a day. So 8 to 9 kilowatts a day on that guy is not bad. And the fact that I can produce 5 kilowatts an hour means that I can run that all day long and I wouldn't even notice it. And I have plenty of power to spare for the rest of the house, the appliances. Thank you. Thank you, sweetie. You got me a shirt? Oh, that's beautiful.
Diary of a Wimpy Kid.
Awesome. Say hi.
Hi.
Here you go, sweetie. Go grab the chair and take it to mom. Hi, mom. So, getting back to this, everything in here is running off solar power. My 2 freezers, the water transfer pump, and the well pump, which fills that huge container there. So doing 5 kilowatts an hour, and assuming that I get, and here in Texas, in South Texas, I get, in the summertime, I can get a full 8 hours of power. So that's 45 kilowatts that I can produce in a single day, not including wind. So our plan is to essentially have all the power available to either relocate to that smaller living area that I showed you, or live in the house just like normal using a portable air conditioner. And I do have a portable air conditioner that I will show you that we have used in the past. So that air conditioner is an 8,000 BTU unit. We have our home, by the way, super insulated in the walls. We have double pane windows all around the house. The insulation in the attic is R49. So if I put that air conditioner in the house and turn the fans on, and we have ceiling fans in every room, the house at 100 degrees outside stays at a cool 72 degrees to 73 degrees inside all day long. And that guy will pull 1 kilowatt an hour. So assuming that runs again 12 hours a day, because it won't need to come on too much at night, and even during the day, it's not on all the time. We're looking at 12 kilowatts out of a production of 45 kilowatts. With my wind power in the wintertime, I could do 2 kilowatts an hour. So in the wintertime, I could, well, even in the summertime, at night you get more wind. So I could potentially produce maybe 1 kilowatt at night from wind. So assuming that I do that for 8 hours, that's another 8 kilowatts. So if you do the 45 plus the 8, that's 53 kilowatts. If that guy pulls 10 kilowatts or 12 kilowatts a day, I got more than enough power to run TVs, to run computers, to cook, to use tools, to do whatever I want to. So that's kind of what I wanted to do in this video, just kind of give you an idea of what are the practical applications of solar power. This air conditioner here, for example, I profiled it before. This is a 5,000 watt air conditioner, and that guy only pulls about 230 watts when it's running, so they're very efficient. So when you're thinking solar power and when you're thinking wind power, think about what it would take for you to live kind of a normal life or a bearable life, let's put it that way. If you had an event where you had to use that and the grid was down, just like it happened in India, right? There's 650 million people in India without power right now, and don't be fooled into thinking that that cannot happen here in the United States. Our power grid is quite fragile, so it could happen at any time. And the word here, that you should take away is protection, right? You have to have protection. So make sure that you have all things taken care of for preparation. You have food. I show you my storage in food. That you have water and the means to extract water from the ground. That you have power to supply your freezers and the refrigerator in the house and so on. So and just limit the amount of power that you're going to consume. So either pick a refuge room in your house. When we lived in Miami and we had power outages for a week to 2 weeks when we got hit with hurricanes back in 2004, we had a very similar process where we took refuge in the master bedroom, and we essentially spent our time there. We had a ceiling fan, we had a window air conditioner, we had the computers there, TV, we had a full bathroom. It was plenty big for us and our son to take refuge in it, and we were extremely comfortable in there. I have a 6 kilowatt generator, Coleman generator that I can use to plug into our systems if we need to. So if I totally ran out of power from solar and wind, I could always come down here and I can plug my generator into that port right there, and I can run my house on generator power. So that's the beauty of having redundant systems, right? Pretty soon I am going to purchase a 10 kilowatt PTO driven generator that will hook up to the back of my tractor. My tractor is a 26 horsepower Yanmar tractor from 1977. That guy can run at 2,000 RPMs for about 2 days on 5 gallons of gas, or 5 gallons of diesel, which is, beautiful. That's very, very, very good. So the next step is purchase a 500 to 1,000 gallon storage tank, move it into that building over there with the boat, and we still have to plant our fruit trees all around the pool area and the picnic area and all around back there, and decorate it so it looks nice. But we have fruit trees, we have essentially a plan for not survival, right, for living. Because you don't want to survive, you want to live and you want to thrive, right? You want to be comfortable as you could be. You want life to be bearable. You don't want the doldrum, right? So stock up on books, things to read. Don't rely on your computers working, right? Have printed material. Have, things that will work in a pinch. I have all kinds of different ways to create fire if I need to, and I have plenty of firewood around me, as you can tell. So a nice barbecue pit, and I have thousands of rounds of ammunition. We could live off the land if it really came down to that, we'd make it. But why just make it when you could thrive by having a little bit of solar power and maybe a generator? So I would say my counsel to you is take some protective steps. Buy yourself a small generator. Keep some gas around. Make sure that that's your first step. Well, not the first step. The first step should be make sure that you have food and water. Make sure you have toilet paper. You make sure you have medicines and first aid kits. And once you have all that stuff taken care of, get you a generator, store some gas, and then look at having enough power from solar or wind, depending on where you are, so that you can thrive. Have a few batteries. They're not that expensive. You know, you can buy a good golf cart battery for less than $100. If you go to Walmart, you can get it for $95. Sometimes, actually, Walmart can get you golf cart batteries that are interstate for about $79 here in Texas. So that's not a bad deal. Get you 12 of those, right? That's not a whole lot of money. It's, you know, it's less than $1,000. You can order solar panels for about $1 to $1.20 a watt. So if you get solar panels that are about 200 watts, you know, that's $200 to $250 for each panel. Buy you 4 of those. That's another $1,000. You got $2,000 in there. A 1500 watt inverter, pure sound wave inverter, you could buy for around $300. Because I know, because I personally bought them. There's one that one of my favorites. It's called Tiger Claw. It's extremely good, very reliable. I love that thing. You could find them on eBay. You could just Google Tiger Claw and you'll find it. So you don't have to spend a lot of money, $300 for an inverter, $1,000 on panels, $1,000 on batteries. Throw another $1,000 for the transfer panels that I'll show you, and all the wiring and doing what you need to do, and you're done. You know, so about $4 grand, you could be protected. So anyways, it's gone on long enough. Thank you for watching, and I'll do another video on a different topic, which will be on Harbor Freight panels. Thank you, and God bless.